All right, hello. As you heard, my name's Jared Rhodes, and we have these like rehearsal sessions that we do with Microsoft where they're supposed to give feedback. So they said that because I called it Beyond Rest, I need to let you know that this isn't about rest. It's about using hardware, not about like web development or REST or anything like that. So that was their first bit of feedback. So what we're going to talk about today is we're going to first talk about .NET development as it touches hardware. We're going to talk about a few different hardware protocols. We're going to talk about a testing harness for hardware and how we can actually use that in an agentic workflow. And then we're going to show some demos. And that's not the exact order. I've rearranged it a little bit, but you get the general idea. Let's meet Jason. All right. The second bit of feedback I got was I was making a joke that Jason wanted to learn how to become a hardware developer because he was scared about all the agents coding, writing all the code. And they said that there's some real anxiety about that, and I needed to cut that joke. So I did. I cut that joke. That's not what Jason is doing. And he needs to justify this fear to management so that he can get some budget to work through this. I stole some slides, or I borrowed, or they gave them to me from James Montemagno and Sam about .NET MAUI and the 𝗦𝗲𝗀𝗀𝗀𝗀 platform. 𝗦𝗀𝗀 has a booth here, and I'm sure somebody will talk to you about .NET MAUI if you ask enough people. In fact, .NET MAUI in the code base that I'm using, that was the base that I started building on. This is a code base. I've been doing this demo set for like a decade now. And I started, Copilot it started to get big. You're supposed to program with GitHub Copilot, and I was like, let's see how this works. And so I started to write it from scratch with that. And the first thing I did was I used MAUI, and this is .NET talk. So guys, .NET, it runs all of it, right? They've got it to where it can run. They've got like .NET packages or .NET frameworks that can run on very limited hardware. It runs everywhere. And if you use MAUI, it can run on 𝗦𝗽𝗀 on the Mac, on iOS, and on Android out of the box. And the reason we're going to be using MAUI and 𝗦𝗀𝗀 is because we are going to be using the hardware on the phone to talk to other hardware or to give a better experience to the user. And out of the box, we get all kinds of things on the mobile phones or on any of the I don't even know what to call, desktop, laptop, form factor, tablet. But they do have things like accelerometers. They do have things like geolocation. Things are a part of the physical world that add an additional layer to the user experience that you don't get from a web app, usually. If you haven't saw 𝗦𝗀𝗀𝗀𝗀, go check them out. They've got a booth. They'll talk to you way more than I will. Just know they have this. They've got some new release for their studio. It's agent first. So they've got all these predefined skills. They have an MCP server for development. So you can just kind of run Studio. It has MCP. It has skills. You can point it at a design, and it can build a very robust app that runs on multiple different platforms and web. Yeah, it's got all kinds of stuff. If you want to know more, they've got a booth. I'm sure they'll talk to you about it. OK. So Jason wants to get started making some IoT use cases because he needs to sell this to his management. Like I was saying earlier, I've been doing this for a long time, and what these hardware experience, what the hardware actually allows you to do is add a new experience that is very different. Who here currently has to scan a QR code to log in now? Like, who here has had to, that new key form factor that you have to do? Right? A bunch of people, right? What you may not know, and that I didn't know until it was on my desktop, is that actually uses a Bluetooth connection. So when you scan that QR code, your phone is actually connecting to the other machine over Bluetooth to verify that you are co-located, and it sends secrets that way. I learned that because my desktop didn't have a Bluetooth adapter, and when I finally got it updated at home, I couldn't log into work for like 4 days until they shipped me the Bluetooth adapter. So it gives a different experience and a different knowledge of how the user is interacting with what you're doing. So again, trust and identity, right? Right now for my workflow, if I wanted to set it up right, I can log into my phone with my face, log into my authenticator, and just take a picture of a QR code. And behind the scenes, without me knowing about it, there's underlying connections and hardware that's being used to verify that all of these things are secure behind the scenes. Or also trust and identity. You can set it up to where if I want to join a Wi-Fi network, I can just tap my phone to an NFC that does the exchange of the SSID and password or any other credentials, and it just works. And I know that they're where they are because they're physically touching the Wi-Fi. It can be context aware. I can know if my user is moving. I can know where my user is. I can know a lot of different things about my user that I wouldn't have as easily through web. And you can actually do, it always feels like magic when your app actually interacts with the real world, when it'll unlock a door, when it'll interact with a machine, or something where you just press a button and physical things actually change. And as I actually got very lucky that the keynote was all about moving to the edge, because I made this slide a while ago. But yeah, we've got a lot of inference that we're running, and we go through cycles of this. Again, I've been doing this talk for a decade. Around 2017, I had the same run the AI on the edge portion of this, because that's where we always go to. The models get too big, and then you can't run them locally. We get in these like token shortages type situations that we are now, so we run it locally, and it's just a cycle that we go through. So things constantly move from the cloud to the edge, and you want your apps to be able to use that properly, and knowing how to use that hardware is key. We're looking at on-device intelligence. We don't have to start with the cloud as the first place that we go to. And if you ever have been in the world where you've shipped apps with physical hardware, there's a bit of a moat there if you're thinking about this in terms of market fit or like as a startup, because it's really hard to copy your competitor's hardware quickly. It's much harder to do that than it is to point a Copilot at your competitor's software and say, can you make that for me real quick? Have you ever got hardware that didn't work? That like you bought it, it got shipped to you, you opened the box and there was a bug? It feels like you bought a brick. Like it feels like the hardware could do 99% of what it's supposed to do, but if there's a bug, you're like, oh, I guess it doesn't work. And that's what hardware bugs feel like. So if we want to do that, we need to, again, when I wrote this, when I was getting started with this, I decided to start it from scratch using the Copilot and other coding agents, and nothing worked when I wrote it the first time. I wrote it, it was like, yes, that's the exact Bluetooth implementation. That's how it works. Yes, that's exactly how NFC works. And then I would go and I would like touch two phones together and nothing would work. So I had to figure out exactly how I was going to make this something that a coding agent could actually program for, instead of me saying, do this, tap, no, that didn't work, tap. So what I did was I built a test harness. So what that really is, I'll show you it. I don't have it here. I've got it in my basement and I've got some cameras pointed at it. But it is the box that I'm developing on, or a box for testing, physically connected to the hardware, and it knows how to use it. So it's not a unit test framework, it's not a mocking layer, and it's not like continuous integration, though it can be used in it. It's just the orchestration that connects to the real system. So what I can do, and I'll show it in a very quick, slick demo. You'll have to see the repo to really understand what's going on. But it composes the inputs of what's going to be allowed or what's going to be used in the particular test. And then it can drive the software or drive the system that's under test, so it can actually run the test, deploy and everything, and it has a way to print out line by line so that the agent can see what's going on as it runs through the test, because as it's debugging the hardware, there is always the possibility that the hardware itself has failed, so it needs sort of a line by line to see exactly what steps were taken and what worked and what didn't. So it's not unit test, right? We're all used to that where you can mock everything, and it's not manual QA. It's something in the middle that's scripted and it's on real hardware, and it allows me to actually work with all of these different hardware components. So it will run on my dev box, and it is able to deploy the apps to the phone, and then it can cross-communicate with the app on the phone, so it can actually send commands on what it's trying to test. That looks a little bit like this. It's USB connected. It can do ADB on the Android. I have a Python file that will let me do it on iOS. And then there are Raspberry Pis that are set up to connect over console, and it can communicate with those because it can iterate over them. And this is what it would look like just to run the test, and you'll see it in the code base. I can ask what hardware is connected. I can then have different ways in which I test as I go through, because if I ask it, if I tell it, make these specific changes, and it makes any changes to, like, let's say the Bluetooth module, the coding agent then knows, well, I need to run the hardware test against the Bluetooth test harness, otherwise I won't know if this actually works. So I can see what is available to the system, deploy it to the system, and run it. So I've talked about it enough. Let's see how much stuff is actually still running in my basement. All right. We'll launch it here. So this is the machine that everything is connected to. I've got two phones connected to it. So what we'll do is, they're not running anything right now. I'll just tell Copilot, run the, no. How do I get my screen, so I'm not, fuck. Un momento. Okay, this will work. Okay, I hope you used your imagination on that. Let's get that pulled back up. It doesn't like it when we change monitors. Okay, so this is the actual machine that's running, connected to the hardware. These are two physically connected phones that you're seeing streaming up here. And all I'm going to do is I'm going to ask Copilot to run the Android NFC test harness. Okay. So because watching coding agents is real fun as it iterates through the first 10, as it tries to remember exactly what I was saying when I said run the test harness, we'll quickly hop over to another view. So this is the hardware setup in the basement. So the Mac Mini is what you just saw me log into. And the actual NFC test are the phones over here farthest to the right. That's why they're stacked one on top of another. The test actually won't work because they're not stacked correctly. So what it'll do is it'll run through it. It'll deploy the apps, and then it'll attach to those apps through the test harness. So let me go back. Take a look here. So I'm going to try to entertain you, because I don't know exactly how long it'll take for it to realize. So it is running the test harness. It's seeing the NFC tier, and it should now start launching the app, and we should see it run up on the phone, because it worked 10 minutes ago before we started this talk. I'm very much hoping we see the app launch now that I'm doing the talk in front of everyone here. And then once we're through with that, we're going to take a look at the different protocols, get a little bit of understanding of what we can do with those, and do it. Okay, so yeah, so it is launching the apps. It now has an ability. So this is what Copilot built for me over like the past year and a half. This nice UI. You're not going to see the actual test run. It is feeding the information back to Copilot, who is launching the NFC radios and putting one into reader, putting one into writer, trying to send a pre-made random packet between the two and seeing if the receiver or the reader has the exact same packet that the writer is sending. Okay, so it returns false. It sees that it can't see that. It says that the Pixel B never actually received that packet, so there may be some problem in there. Now, I'm not going to show you a full debugging of hardware that is physically disconnected from me all the way back in Atlanta. But you get the idea that if I want to start making changes through a coding agent, this will tell me if my actual hardware works. And so now that we've gone through that, let's go back and actually learn a little bit about the protocols. So I'll cover three main protocols. I'll cover Bluetooth Low Energy, NFC, and Wi-Fi. So for Bluetooth Low Energy, it came out in about 2014. It was supposed to be a way in which you could use Bluetooth in a, I'll call it a REST-like fashion, since we have REST in the title. So I'll go through the heart rate service from the Bluetooth spec. So the way the Bluetooth spec works is if I go to the Bluetooth website, which has the spec in it, I can look for a pre-made set of services. Those services all have a unique UUID. If my app has that UUID, or let me say instead, if my hardware returns that UUID, I now know that it's compliant to a specific set of endpoints. So if I want a heart rate service and I'm compliant to the spec, any device that has the heart rate service works. That's how it's so easy for your device to know, or your app to know, the battery of all these different things you connect to, because the battery is a pre-made service in the Bluetooth spec. Okay, so let's go over these real quick. This is what the diagram looks like from the Bluetooth spec for the heart rate service. So at the highest level, under the device, is the set of services that it has. So it's the logical collection of data and associated behavior for a particular function or feature. We're going to relate this back to web development because that's the easiest way for me to get these ideas across. So if I were to have a service equivalent for Bluetooth in the web, that would be the root of an API path. So if I wanted a heart rate service in the web, I would have it at /heart, or heart rate service. Or right here in my notes, v1 heart, so it can host multiple services, and that would be one of them. And the way I'm going to discover that is I can actually just pull in a open source library that has the ability for me to scan for devices. If I see one, I can connect to it. I can actually see all the different services that are available from that device. And if I see one that I like, I can go ahead and say that it's compliant to use. Now I'm showing a different service here as the example. I've actually got one that's humidity, temperature, and an LED. And that's just because it's really hard to do like if I want you to go and take my code base, it's really hard for you to do a heart rate like example. It's a lot easier if I give you one that's just one sensor and one LED. So first we'll go and we'll see the service. we see all the different UUIDs. I know which one is for the service that I'm looking for, so I connect to that, or I get that service, and then I can use that service to then use the characteristics to edit the functionality. Well, Jared, what are the characteristics? Well, the characteristics sit under the service. They are resource endpoints. Each characteristic is like the heart rate or the heart rate sensor location. Think about that if we're talking about it in web terms, right? Now I have the different endpoints that I want underneath heart. So I'd have one for heart/rate and one for heart/sensor location. To break it down even more, you'll have a characteristic, which we just described. You'll have a UUID, so each one will have its own unique UUID so that when you're spec compliant, you instantly know which endpoint is which. There's going to be an in-memory pointer. Don't worry about that. And then you'll have permissions and properties described on the characteristic, as you can see up here where it says read. So those are going to be equivalent to my HTTP verbs or authorization, because it's not exactly a one-to-one. So a read is going to be equivalent to a get, a write is going to be equivalent to a put and a post. And then there's a little bit difference where we have the notify or indicate, and that's more of a streaming service. If I'm looking for a heart rate service, I kind of want it to stream the heart rate to me rather than for me to constantly request what is the current heart rate. Or if I want something like a notification of the battery life at a certain level or yada, 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 that's how I can do it through notifications. And then finally, the actual value itself is obviously going to be equivalent to the response body of that HTTP REST endpoint. And it's important to know that because we are at the low level here. So I need to know the values type so that I can understand exactly, like, is it 2 bytes? What do those 2 bytes mean, and how do they map back? And this is what it looks like if I want to read or write. Once I have that characteristic that we saw on the last slide, well, it just lets me read it, and I can take it and I can convert it into whatever value equivalent it needs to be. In this case, I'm reading a float, or excuse me, an int16 that I'm then converting into a float, because that's just how it works for that particular service. And then for the toggling of the LED, if I want to write, I'm just writing. For it, it's a byte array of 1 byte. It's either a high or a low, and that determines whether the LED is on or off. But I just call write async, and I give it the expected body of that as a byte array. And then finally, last little bit is the descriptor. So the descriptor provides additional information. So you can think about that as like an HTTP header. It's just more information about the characteristic, like can it enable notifications? Does it have different capabilities that aren't exposed in the upper level of the characteristic? Okay. So that's going to be the Bluetooth low energy. That's how you would use it if you want to set up something that utilizes a device that is Bluetooth capable. And then Jason's wondering, he heard that you could do like indoor GPS and stuff like that. And I mean, at this point, I've seen it to where you can do x-rays of people's bodies through the wall using Wi-Fi. So yes, with Bluetooth, you can do indoor GPS, but you can basically do that with any system that has access points over distance. So you can see the strength of the signal. All right, so near field communication, it's where you tap, right? Everyone's used tap. In fact, most people know it as the like tap to pay for Apple. In fact, the reason NFC, in my opinion, isn't as prolific across the industry is because Apple, for nearly the first decade of the iPhone, didn't expose NFC to the user layer. So Apple could use it for tap to pay, but as a user, you couldn't actually invoke the NFC hardware until about 2018 or 2019, which was a little late for people to start adopting it en masse. But now we have it as a bunch of different things. You can use it for ID. You can use it for access points. You can use it for payment systems. You can use it for all kinds of things. If you've ever used RFID, which I'm sure some of you have, it was the previous widely accepted tap protocol. Due to time constraints, we'll just say that RFID is like a barcode, right? You got a bit of a limited set of information, whereas NFC is going to be more of a QR code. It is much more complex. There are different tag types that you can write and you can read from. To give you an idea of even further into that, like the Japanese payment system uses a different tag type than the US pay system. They're just different tag types for whatever reason. When they were writing all the specs out and people were adopting it, payment systems there work different than here by a small deviation of the tag type. And you can have everything. You can even have it. My nephew came to visit. He's like 2 years old, and I had an NFC card, and I set it up just to be different URLs. So he would tap it. It's a new URL, and he loved it because he liked to do it at the hotel room where he could scan, and he was just loving it. Every time he could go to a new URL, and that's the kind of stuff you can do with NFC. So this is what it looks like if I want to read a message. I basically just say, I have a certain tag type that I'm looking for. I would like to turn on the radio, and if you receive a message of this type, please notify me that you have. And then you have to play with the funky .NET wiring of events back to callbacks and make sure that you capture that message. Similar, if I want to write, I'm going to say, hey, I would like to publish this message, and then at any point which you see that radio has connected and actually sent that message and received a confirmation, please inform me of that, and then that's how I write. And I could say, okay, as you see, I've got this on tag discovered and start publishing. You just literally say, please start, and then someone's got to figure out, just like when you're tapping to pay with your credit card, have I actually invoked this? Okay, in the instance of, for time's sake, we're going to skip a lot of the NFC, and Jason says, I bet I can set this up as a communication protocol for large data exchange, because why not? We always try to extend things well beyond what their usefulness is, and technically within the NFC spec you can. There's NFC peer-to-peer. If you think about it, when I tap to pay with my phone, I'm writing. Whenever I tap the card and it gives me a URL, I'm reading, so it can do both. So I can toggle between reader and writer mode, and technically I can have long payloads in writer mode that gets read, and then toggle a swap and write, and it is a part of the spec where they can communicate to phones and or two devices. And the good thing there is you know that they are physically connected, they are physically touching, so you know where the wireless communication is coming from. Just interesting if you ever want to set something like that up. We've got the USB, so I'll go over this real quick because we're running out of time. Whenever you plug something in for USB, you hear the boop boop. There's actually a set of things that's happening. First, the machine is sending the device the reset signal. It's saying, hey, thank you, I saw that reset signal. And then it's sending, hey, I need you to tell me a lot about yourself. And it'll say, okay, here's my descriptor. The descriptor is important. If we go back to that video of my basement, I've got like 3 or 4 different USB hubs all wired into each other. So the descriptor is going to have to tell it, hey, here's my address here, 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 and here, and that's how you're going to send me a message. It'll assign it an address based on what it received in the descriptor. You'll get a confirmation, and then finally you'll send the device config, and it will acknowledge the config that you sent it. Okay. I've got a basic demo in the code base where we talk about how to take 2 devices that can use USB, open and do a bulk transfer. USB has similar to NFC where there are so many different device types. If I were to tell a coding agent to go through, iterate, and prepare them all in my code base, I would run out of tokens before the end of the day. Don't worry about getting all the devices. Just know that you can program for USB, and it's nice. It has heavy data utilization. Most devices support it. All right. Real quick on that, just because I've been doing this talk forever, I want you to know that Android, in the case of USB, is not iOS. It is not equivalent to iOS. It is not equal to iOS when it comes to USB, because you need an MFI certification if you want to be able to connect USB's devices compliant with iOS, which is a process that I'm sure adds a security layer. It gets you I think it gives you a special piece of hardware that has the certificate stored that you're going to need to communicate. But either way, you need to come up with a lot of money and deal with Apple a whole bunch if you want USB compliant devices to work with iOS and Mac. Okay. Jason's ready. He got that budget that we were talking about, so he's going to go through that certification process. I had to do it once, and I'll never do it again. I don't care how much money you come back with. So I want to wrap up. I know I was kind of all over the place where we talk about getting the hardware set up so that I can use it with coding agents. But what I would like you to do is I want you to know that having an app that can actually interact with the real world is very, 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 I don't know, it's fun. You get tired of making web apps after a while, and if I have to make another agent, I don't know if I'll be able to continue going on. But what I can do when I have my actual hardware integrated real world interactions, I have a physical device, I have a physical product, it actually feels like magic when things change. And it feels like that to the user as well. So if you check out this repo, you'll see how it runs the test harness, how it actually can deploy the device, set up a server so that it can communicate with it, how you can add it to your CI if you want to, so that if you make changes that need to run against existing hardware, if you've ever done a device farm where you're testing out all the different devices for your mobile development, it's very similar to that. You just need one harness to test out that hardware. And then I only have the stuff physically connected in my basement set up for this, and if you want to take this as a standard for how you're doing your hardware, you can extend it. I've got a buddy of mine works in medical devices. We're testing it out with FPGAs so that you can configure circuits through the FPGA to test against. But that's it. If you have any questions, we can take it over there. Thank you for coming.